Hello, everyone. Welcome to this next talk titled The Quest for the Best, How to Choose the Right LLM. Our next speaker is Emma Mani from Financial Times. She is a data scientist at the Financial Times with nearly 3 years of experience. She holds a first-class degree in business analytics and has expertise in natural language processing with a focus on large language models and generative AI. Sorry for that. And generative AI. Of course, this is the last session for today. We're hoping that you enjoyed all of the sessions. If there are any questions, probably we'll try to stick to the time. Afterwards, there is a huge networking session outside. You can meet the speaker, this one, Emma, and the other speakers. So good luck with the session, and let's welcome Emma to the stage, please.
Thank you, everyone, for coming, and a big welcome to this, the final presentation of the Oktoberfest. I really hope you've had a smashing day. We've seen some really fantastic talks, some great insights, and it's been a real pleasure to be part of the lineup this year. So in terms of this particular talk, and thank you so much for coming, we are going to be focusing on the quest for the best, how to choose the right LLM. So really in this particular presentation, we're going to focus on the process, because we're now in a world where there's so many different models. It's actually quite a scary task when somebody asks you, pick a model for the job. So what's coming up? Well, first of all, you'll hear a little bit of intros from about me and the FT. Then we'll discuss around where we stand on generative AI at the Financial Times. And after that, we can begin our quest, which is trying to find our models amongst this really big pool of different options. This comprises a range of industry methods, vendor methods, and of course, the process that we used to choose our selection at the Financial Times. The second part of the quest is then taking our top candidates that we have selected and putting them to the test. There are 4 different tests, and part of this process we will look at is the prompt engineering techniques, the parts of the metrics that we're going to compare, and ultimately choosing a winner. The final part is talking about into the future and beyond. We know that these models are continuously changing, and it's really important that we find a baseline that can quickly and efficiently compare these models to give us a contender. So for those of you who haven't met me, hello, I'm Emma. I am a data scientist, as was mentioned in the intro. I started at the FT as a core data scientist, working in recommendations, segmentation, and lifetime value. More recently, I transitioned to a pioneering new team called Accelerate AI within the FT that comprises a bit more specialists around the natural language processing, the large language models, generative AI, to support the newsroom. Now, some of you may have heard of Ask FT. For those who have, it's a product that we have launched earlier. And just to clarify, I won't be covering anything in this presentation on Ask FT, as Ask FT is part of the FT professional pillar. So just to clarify that. In terms of my degree, that's where my interest in natural language processing and generative AI and all that kind of stuff came into the mix. But outside of work, as you can see, I do enjoy doing some of the other things, like a qualified skydiver. There's me at around 12,000 feet. And I'm also a qualified advanced open water scuba diver. Come in, there's lots of seats over here. So that's a bit about me, but what about the Financial Times? So the Financial Times, we are one of the leading world news organizations. We're recognized internationally for our authority, our integrity, and our accuracy. In terms of our global paying audience, which is our new North Star metric, it represents our digital users, our print consumers, and our events attendees. That figure stands at 2.78 million as of this month. Now, in terms of our data science teams, we're located across London in the UK and Sofia in Bulgaria. We combine a range of data science, ML engineering, ML ops, engineering across different business functions. Now, just at the top there, that's our Bracken House, our London HQ. It's a very historical building, but it's a very cool building, so that's just to give you a bit of a visual on that. And in terms of the diverse content offering, there's lots of seats just down there, don't worry, no worries. There's diverse content offering that we have for our subscribers every day to bring them up to speed with all of the breaking news, including things like world politics, climate, technology, life and careers. So we really have a diverse offering for our subscribers. So with all of this, you might be wondering, where do we stand on generative AI and the FT? I'd like to interrupt this broadcast with a message from our editor. So last year, our editor sent a message to our subscribers detailing that our journalism will continue to be reported, written, and edited by our humans. And to this day, this remains. And with that in mind, everything that you see in this presentation is around internal experimentation and working with the newsroom to optimize productivity internally. So we're still keeping this standard as we move forward into this industry. So thanks from the editor, but on to the quest. So we start by choosing our candidate models. Now this is very scary because there are lots of different models now. I'm sure you've all looked at them, wondered how good they are at different tasks. Which one do I pick? Now the Accelerate AI team, to begin with, we narrowed the scope, so trained the way that we were looking at these models to help us understand what way we could narrow our list. So the first thing was to select a model that harnesses our high-quality FT journalism. For the Accelerate AI team, our initial sort of purposes of choosing this model came from summarisation and broad experimentation. So the idea that lots of people are going to be in contact with this model, so they're going to have a lot of requests and things like that. Now, to get an idea of the standard of an FT summary, we have this discovery in the first FT newsletter. Some of you may have seen it. It's a core newsletter offering that we provide to our subscribers every morning at 5 a.m. in the UK and at corresponding world regions in different times. Within this newsletter, there's an awful lot of information and stories to bring you up to date for the day. In particular, the 5 more top story section, which you can see here on the screen, is a perfect example of a summary of a single article. Sometimes there's multiple articles, but on the whole, it's single articles. And these are written by our FT editors every single day. So really good standard there, but we will come back to First FT later on. So if you're kind of beginning your search and you're thinking you've got your scope, where do you head next? If you're going for general options, there are the leaderboards to start off with. I've put a couple just on the board to give you an idea. The first one being from Hugging Face. It's the massive text embedding benchmark. Some of you may have well used it. It's a really great place to look at open source models. There's a lot of features you can adjust on that particular leaderboard, such as the model size, the task at hand that you want to look at, even the language that you want to analyze. If you're more interested in the closed players, the bigger players of the game, you can head to the LM Arena, which is down at the bottom here. It is a research initiative by UC Berkeley and Skylab, UC Berkeley Skylab and LMSys, and it keeps up to date with a lot of the models that are coming out, so a really good place to start for that. Although there has been known to be a little bit of overfitting, so do take the results with a pinch of caution. So past the leaderboards, the next part to look at is training dataset diversity. So thinking about your use case, you might want to really focus in on what type of data you're going to be giving to your model. Is it short form? Is it social media? Is it a particular language? So basing that in your mind, you can look at the training data set that was used to train these different models and make sure that they align. Knowledge cutoff date is another really interesting parameter because you might want a model with a really recent knowledge cutoff date. That might be very important to you. But in the event you have a use case where the model's knowledge cutoff date is older, you might have to make that trade-off to get a slightly older model for that particular purpose. Now, for researching into industry use cases, if you find that other organizations have tried your particular use case, they've found a specific model that works well for them, you can start your process by using that as inspiration to find your model. Now, vendor methods are the next step. So if you're more interested in OpenAI, Anthropic, that kind of space, you can head to the documentation. Seems like a simple thing, but honestly, it's really the best place to start. Here you can really begin to understand what's going on with these models, how you can implement them into your architecture, and how to optimize your prompts. Now, within that documentation, you can find these performance statistics which benchmark against competitors. So on the right here, we've got Anthropic's Claude 3.5 documentation where they put it through a few different general knowledge sort of tests that are pretty complicated and then benchmark that across different models. So you can get an idea if a model is pretty good at coding or something like that. OpenAI, if you go really deep in the documentation, you will find some as well. So a similar kind of benchmarking aspect. Again, it's just to help you understand what the sort of particular areas a model's good in. The final thing is around system prompts. System prompts are where the magic happens. You start to learn a bit more about the model, what kind of makes it a really strong, model in the way that it's formed, and it can also help you to optimize your prompts as well. Now, on the FT side, we actually had a really good head start. So we had some connections to the big players, OpenAI and Anthropic via AWS. We actually had a deal with OpenAI earlier on in the year on content licensing. But internally, all of our employees have access to the OpenAI API and the chat UI. The technical teams can also request access to the Anthropic models. So this really provided a strong head start and a foundation for us to choose from. So you might think, okay, well, you've got those to choose from, just pick some of them and see what happens. It wasn't that good, actually, because we had a bit more of a complicated access. So this project that we did was around March, April of this year. So if we think back to March, April, it was before Claude 3.5 Sonnet was released. It was before GPT-4o, which I can't quite believe, and O1 models. So none of that existed. So our list looked very different. We had GPT-4 and GPT-3.5 on the OpenAI side, and on the Anthropic side, we just seen the Claude 3 models released. So we still have to make a decision to 2 top candidates to make this kind of list narrow down further. So this is where we bring back our initial scope. So thinking about that summarization and that broad experimentation. So to give you an idea in terms of cost, some of you may well be familiar, GPT-4 is around $60 per million output tokens, whereas GPT-3.5 is around $1.55 per million output tokens. So quite a substantial kind of cost difference there. And when we're thinking about broad experimentation, we might not really want to spend that much at this point, so we can actually look at a different pairing. So that left us to these 2 models, Claude 3 Haiku from Anthropic and GPT 3.5 from OpenAI. This website is called context.ai. It was a website that I came across during the process. Very cool website to compare the models side by side on a bunch of different parameters. They're very good at catching up with all the updates, so do scan the QR code if you want to test that out. I'll just leave you a lot of phones. So now we've got our top models, we can prepare the battle ring. So in the OG corner, it's GPT 3.5, and in the blue corner, new kid on the block, Claude 3 Haiku. So what are we going to put them to battle on? It's going to be summarization. Now you might be thinking, okay, summarization, we're taking an article, we're turning it into a summary. Well, to get an idea of what that actually means, let's bring back our first FT, 5 more top stories article summary. So to get an understanding of how we can design a prompt that can help get to this level of standard, we need to break the summary down into parameters. So the first thing being that this is a single article summary. So there are some summaries which are multiple articles, but we wanted to focus on the simple aspect, so focusing in on single article. Then we have length, so it's usually about 3 or 4 sentences. We have tense, which is past tense. We have tone, which is a sort of news, factual, informative tone. And then we have these slightly more sciencey parameters, which are a bit cool. So we have curiosity gap. Now, this is something that we learned about what the summaries are designed with. They are giving enough information to give you some information about the potential topic, but not enough information that you're curious to click on into the article. So we needed to kind of in some way weave that into the model's sort of intelligence, if you like. We have some bold formatting going on in there, which is quite an interesting aspect. And the final part is this hook line. So that is the line which the subscriber, the user, the reader will click on. Oh, wow. Very dramatic. The hook line will basically be the space that the reader is clicking through to the article and often is interchangeable with the topics of that particular article or summary. Now, we evaluated this particular sort of parameters and instructions. Well, hey, we're back on. with the first FT editors, so these are the people who write these every single day, we confirmed all of these instructions, did some close research with them to really get an idea of how this comes together. So now for the prompt that we use to get to the standard of these particular summaries and really to inject all of those instructions. I hope you're ready, because this is the secret sauce here. What a fantastic prompt, right? I mean, I can see all of you like smiling, laughing. I know it's 4 o'clock, but this is obviously not our prompt. Our prompt was far more complex and more comprehensive than what you see there. So to break down how we set up the prompts, we also had to factor in that we have 2 different models. So we need to tailor these prompts to each model, and we need to follow this schema. So first of all, introducing a role. Then we look at the task, so providing a clear description. The core parameters, this is inputting FT style, tone, truthfulness. And the task-specific parameters are where we start to weave in the more specific stuff, so length, tense, vocabulary, the curiosity gap. And then this final step, which is around review. So we discovered that when we add a little section at the end of the prompt, which double checks some of the key factors we're interested in, we tend to get more consistent outputs. For example, double checking that the length is the length that we've asked for. Double check that we haven't content duplicated anywhere, because especially in summarization, we have a very limited space, so we don't want to kind of lose any space to unnecessary text. You can also include a level of moderation at this step as well. So generally, they follow that structure. To give an idea of what the prompt sort of had in it, so here are some snippets from the Claude 3 Haiku prompt, the actual prompt. This is the user prompt, so it's not the system prompt. We chose not to opt for that. But the first thing is to introduce the role. We took an audience persona, and that's quite an interesting perspective, but it seemed to work well for short-form content. So in terms of this, it's you are an avid reader of the Financial Times newspaper. Task, your task is to generate a factual and truthful 4-sentence preview of the article. Each sentence must be short, no longer than 20 words. Giving the context, most of the key information will be included in the first 2 or 3 paragraphs. And then in core parameters, the summary must be truthful to the content of the article. Do not lie. So we're telling the model to behave. Task-specific parameters, so this is where we introduce the tone, so keeping a news tone, don't make judgments. And then this curiosity gap was really difficult to explain, really, because we can't just put into the prompt, insert a curiosity gap, please, because it won't understand what that means. So you really have to break down the task into what it actually, in theory, means, which is, at utmost priority, think about why the reader would want to read the full article after reading the summary you create. So inciting that curiosity in that point. In the first line, format the first sentence in bold. That's how we deal with the bold formatting. And then this final bullet point is around the hook line. So that 4th and final sentence must be extremely short and contain a phrase inside the brackets, because we wanted to flag to the testers what the sort of hook line part was. Similar to read the latest on. Now that's the first part of the hook line. The second part of the hook line requires a sort of a nature of named entity recognition. So we need the model to actually consider what the article is about, whether it's a person, an organization, an event, and actually turn that hook line into a relevant hook line for that summary. Then we had that final step of review. So here we're picking out some vocabulary that we don't want the model to use, that we've seen it sort of use in past testing, and then checking the length, as I mentioned before, and also then for that content duplication, finally, making sure that we don't have any of that. So we've got our models, we've got our prompts, we now need our baseline to compare them against. This is where the golden corpus comes into play. Now, how do you get a golden corpus? Well, first of all, you move from unstructured to structured data. That makes for a happy data scientist. I am a happy data scientist. But actually, from the first step, what we're doing is to go back to that first FT newsletter, and we're going to extract those newsletters from BigQuery. We have them stored, they're written every day, so we have quite a large volume. But we need to now, from those newsletters, extract the body text. So that contains all of the information from that newsletter. The thing is, for our purpose, we're only interested in that 5 more top stories. So we need to identify, using some string matching, regex, that kind of stuff, where the 5 more top stories sit. So that breaks the newsletter down into a sort of, still a chunk of text, but a bit smaller. So to dial that down even further, we then need to pull out each summary from those 5 more top stories into their own row of the data frame. Now that's great. So we have a newsletter and we have the summary, which the editor wrote. Okay. But we don't have the article that was used to base the summary on. Okay. So that was actually something that became a manual process of this whole kind of cycle, really. To get the article that the summary was based off of, we actually had to go into the newsletter on ft.com, find the summary, and get the article information and pass that back into the data frame. The reason why we had to do that is because our content management system doesn't store that information in the body text. It's done on the kind of front-facing. But once we'd done that, we'd have the single article input that made the summary, the golden summary, and then the information surrounding it. The final check was around manual inspection, just to make sure that there weren't any outliers, any multiple story inputs. There was one, so I had to take it out, and that's why the next page is a slightly imbalanced number, but you'll see what I mean. So when you've gone through this process, you come up with 24 summaries with 5 different newsletters published this year. And generally, the frame sort of looks like this. You've got a newsletter ID, and then you've got the golden summary, which was written by the first FT editor, and then the input article details, which is going to be really helpful for our testing process. Now, when we go back to the tests, which I'll come to later on, there are 4 different tests, which means we're going to reuse this golden corpus 4 different times. And when we're going through each test, what we're looking for is the golden summary per summary, and then we're looking for the answers from our models. So we have the answer from Claude 3 Haiku and the answer from GPT 3.5. This is going to make it really easy for us to compare across how the models are doing. And we had to regenerate this table multiple times for fairness, because we all know when we rerun AI, we get a different answer every time. So that's how we kind of evened it out. Okay, so we've got our models, we've got our prompts, we've got our baseline. Now we need to look at the quantifying of metrics. How are we going to score these models into getting our winner? So this is where we bring back our vectorizer, our all-million LLM L12 V2 vectorizer, which is a sentence transformer. You can find the information on Hugging Face. We host this internally as an API in the FT, and we therefore can use this as a service across different options. So what we do is we vectorize our summaries. So we take our golden corpus summary, we vectorize that into our golden corpus summary vectors, 384 dimensions, if you're wondering. Claude 3 Haiku, the output, we send that through the vectorizer, and we get our Claude 3 Haiku model output vectors. GPT 3.5, our model output, we send that through the vectorizer and get our output vectors. So this is kind of the process that we're moving forward on. Now, if you're interested in the article vectorization project that the team went through to decide on how we got to this vectorizer, please do scan the QR code to take you through to the blog post. So yeah, that's an interesting read. Lots of phones again. Thank you so much. Oh, is it? Okay, that's great. Thanks so much. Become a member of Medium, because it's a great platform. So you might be wondering then, why do we need the vectors? Well, this is where we bring in our favorite metric, cosine similarity. So cosine similarity is really helpful for this particular task, because it's a measure of similarity between vectors. Now, our vectors are representing text, so that can broadly mean that we're looking at semantic similarity between the summaries. In general, the higher the score, the closer the vectors are together. So in our particular space, we were looking for a score of around 0.8 and above, which would indicate, highly similar summaries, which is kind of okay for us. You might find in your own experimentation that lower might be better or higher might be better for you, but for us, 0.8 was cool. And then to just help with analysis, I introduced this kind of column, which you'll see on the next slide, which was distance check. So that alerted true when GPT 3.5 had a greater score than the Anthropic Claude 3 Haiku model. You could do it the other way around. It doesn't really matter. It's just to give you a visual on how the models are doing. So visually, what does this look like? Well, we take our golden corpus vectors, we compare them with the OpenAI vectors, we get our cosine scores in that sort of column there. Then we have our golden corpus vectors, our anthropic vectors. We use the same sort of SciPy cosine module, and then we get our scores there. And then we use that distance check to compare across and see which model scored the highest for a particular summary. Okay, so we have our models, we have our prompts, we have our baseline, and we have our quantifying metrics method. We now need to introduce the battle rounds. So round one is going to be the original prompts in their respective models. So Claude 3 with its Claude 3 Haiku model, and then obviously a GPT prompt in the GPT model. In round two, we are going to switch the prompts. So this is going to look into the versatility of the model. In round three, now this is a little bit of info as well, OpenAI GPT 3.5, when we were constructing the prompt, we noticed that it actually really struggled with the hook line and the bold formatting aspect that you saw earlier on. So we just decided to leave that as 4 plain sentences to see how it would perform. So to make sure that there was no unfairness in our testing, we rework the anthropic prompt in that particular round, and we compare the two together. I'll show you a visual shortly. The final test is temperature. So for those who haven't come across temperature, it is a parameter that you can tweak to allow the model to be more creative. It also can lead to more or less hallucinations, depending on which end you go to. Our baseline is around 0.7. So I decided to kind of look either side of that to see if there was another optimal temperature to use for each model. So test number 1, what does that look like? So here we have the original prompts. What we are doing first is to take the single article input for the article of the summary we want to create, bring that together with the OpenAI prompt, send that to GPT 3.5 to get our OpenAI summary. We then take that with the golden summary, send them through the vectorizer, and get the cosine similarity scores. We then have anthropic, so same thing again here. Anthropic prompt is combined with the single article input, sent to Claude 3 Haiku. We get our anthropic summary. We take our golden summary. We send them through the vectorizer. We get the cosine similarity scores. Then we compare those cosine similarity scores, and we decide the winner. And here are the results. So in the first test, this is a really interesting depiction of the results in terms of what it means. So what it means here is that if we optimize the model in a way that is suitable to that model, you're likely to get much better results. We can see a lot of the scores are in the sort of 0.9 region. So really, to make sure that your prompts are aligned with what the instructions sort of tell you and guide you to do, follow that as closely as you can, and you're likely to get much stronger results. What we can see here, though, that is Claude 3 Haiku has a much more consistent result score, and it actually won the test 15 out of 24 summaries. Test number 2, so same as test number 1, but this time we switch the prompt. So to get an idea of what the results are for this was the answer. Now, what this means is that we've put the OpenAI prompt into Claude 3 Haiku. So we know it's not going to do as well, but really what we're looking at here is that OpenAI's GPT model has not done well at all. So it's really suffered in performance, and it means that, you know, if we're not optimizing our prompt for that model, we're going to see really bad results. Nevertheless, Claude 3 Haiku shows its versatility because it still manages to pull out of the bag quite a few ones that are fairly strong and close to semantically similar to the golden corpus. So on that, Claude 3 Haiku wins 19 out of 24 summaries. So test number 3, this idea of removing the formatting. It's a bit stakeholder specific, but just to give you a visual on what it involves. In tests 1, 2, and 4, we have the output from Claude 3 Haiku on the left there, so you can see the bold formatting, and then you can see the hook line that we've created with that sort of entity recognition aspect. And that was what we kept for those tests. But in test 3, to even things out, we remove the bold formatting, we remove the hook line, and we replace with an additional sentence. So that allows us to get an additional part of semantic difference in there. So there could be quite an interesting results from this. So in practice, what does that look like? Well, it's actually the same test as test 1, except the difference this time is that we've just reworked that prompt a little bit. So the results, it was a draw. 12 out of 24 summaries for each model. And really, I think this just reinforces the need to really optimize and push your models to as close as you need the outputs to be. Because once we kind of removed all that additional formatting from the Anthropic prompt, it dialed its performance down to OpenAI's level. So this was a really interesting capturing of insight that it is so important when you're using these models to optimize. Final test then, things are heating up in here. We've got the temperature. So this is basically test number 1, but this time we are changing the temperatures from 0.5, 0.7, and 0.9. So just to look at these side by side, and this is really starting to go into the model's stability. Is there a temperature that it works particularly well at? Is there a temperature that we should be choosing? Side by side, what we can see on the right-hand side, so we have Anthropic here, it's a much more stable kind of set of results for Anthropic. So generally, temperature doesn't seem to affect it too much. On the OpenAI side, there seems to be a party going on because the temperature is a bit of a factor that needs looking into. So let's zoom in and have a look at 0.5. So 0.5 on the more restrictive side, we can see that Claude 3 Haiku's kind of got a bit of a drop in performance, but it maintains a higher consistency compared to GPT 3.5. So perhaps 0.5 is not quite good for GPT 3.5. So for Claude 3 Haiku. Now 0.9, so 0.9 is a much more creative setting, so we're allowing the model to express itself a lot more, and GPT 3.5 seems to love this, so the distribution is really nice there, but what we can see in Claude 3 Haiku's position is that it's kind of a bit uncomfortable with this freely new experimentational state, because what we have is that when the results are bad, they're really bad, and when the results are good, they're really good. So that's kind of an interesting indication. Maybe it tells us that GPT 3.5 works better at 0.9, but actually Claude 3 Haiku, maybe not. 0.7 as our final sort of comparison. We can see here that GPT 3.5 now, because we've restricted it a little bit, is sad and therefore performs slightly worse than before. But 0.7 seems to be quite an optimal temperature for Claude 3 Haiku. It's much more stable. So you can kind of see how the different temperatures have affected the models in different ways. So that concludes the testing process, and you might be wondering, or you may have guessed, who the winner was. Claude 3 Haiku. Congratulations, Claude. You did a great job. Some additional factors that make Claude 3 Haiku a winner. So you saw the internal evaluation on summarization. It outperformed GPT 3.5. Now, we gave all of these summaries to our editorial testers to have a look at them and give us their feedback. And on the whole, they really preferred the Claude 3 Haiku outputs. Also, Claude 3 Haiku has a really recent training data set. It's cost-effective, which is very crucial for our summarization and experimentation requirement. It's fast, and it has a super large input context window of 200,000 tokens. So in summary, if you need to compare 2 or more models, it is possible, as you've seen today, and this is really just focusing back into that process. If you've got a baseline that you're trying to get to, a vectorizer or some way to quantify the metrics, and then, of course, stakeholder support to help you with your optimization of prompts, then you're well on your way to kind of implementing this process. You can move on then to creating your custom prompts for the models you want to test, and then run the tests as so. Test 1 being the original prompts, test 2 swapping them over to look at that versatility, test 3 focusing in on any stakeholder-specific requirements that you may have, and finally looking at temperature in test 4. Now, what's really important to mention here is that some of the models you've seen here today are on the older side, and that's why this process is continuous. We can recycle this process and interchange between different models as we go forward into this world where we are evolving into so many different options. And that brings me to future models and other applications. Now here, I've kind of anticipated some of the questions you want to ask me, so I'm going to try and beat you to it. So the first thing, can you apply this to other models? You absolutely can. There's no reason why you wouldn't be able to interchange, 3.3 Haiku with 3.5 Sonnet, or GPT with another different version. So it's very easy to change up the models. In terms of other tasks you could apply this to, any sort of form of broad summarization will work quite well for this, but you could also look at translation or even possibly the results of information retrieval. In terms of open source models and fine-tuning, it's not something that we've explored at the Financial Times because of our connections with OpenAI and Anthropic. So while I think that if you did opt for that, you might get some really good results, it's something that we haven't really explored, but there's no reason why you couldn't test it out with that. What happens if we change the vectorizer? Well, in this case, and our vectorizer is slightly on the older side, but it still works very well for our use case. As long as we keep the vectorizer the same and the vectors the same throughout the testing process, that's really important to make sure that our tests are fair. And also checking that the vectorizer that we have will effectively reflect our content in the best way, but then also that we can computationally do all the calculations as well. More than 2 models. So here, if you want to test more than 2 models, you absolutely can. I think it's a bit difficult on more than 2. You could try, but I think you might end up doing the battle of the battles rather than just having like different ones to go against. And finally, looking at other types of validation. During this process, I probably went through more than 50 summaries, and working really closely with those first FT editors, I learned an awful lot about how these summaries were constructed. So in general, your eyes and your own experience is just as valid in the process. So human evaluation is very important in this process. Now, on the screen, we've got some sort of preempting there. We have Claude 3.5 Haiku and Claude 3.5 Opus, which are due to be released later this year. And this idea of GPT-5 is still in the mist in the future. We know it's probably coming. We don't know when, but they'll be back, I'm sure, for a rematch. But for now, that's all from me. Thank you very much.
I think we're open for a couple of questions.
Thanks. I never imagined I would subscribe to the Financial Times to only need to subscribe to Medium for another article. But yeah, I think it's a very rigorous testing procedure you had to compare for the summarization task across, although kind of an older 2 models. But my main question here is like, do you have a use case where you're trying to write a more reactive summary to, say, a new ruling or a new company release? And when you've experimented with those, what evaluation methodologies have you used for those? Could it be some sort of LLM-based judge for factual relevance or context utilization? Yeah, have you used those?
Yeah, so just to clarify, is it sort of fact-checking type stuff, or is it?
Yeah.
Okay, so we're looking into this. It's a really hot topic, I think, at the moment, because one of the things that obviously is key when you're using AI is that obviously the outputs, we're trying to trust them in some ways, but we know we need to validate them in some way. So you can use sort of embedding approach, like a semantic approach, but I think that doesn't quite cut the kind of the metal for it. The LLM approach is sort of a risky approach, I think, because you could get sort of different outputs. But I think, you know, we have to experiment and see what the best way to do it. Actually, there was a really good talk on Neo4j earlier that had a very good RAG system that they had sort of a fact-checking thing in there, which I thought was quite interesting. But yeah, it's something that we're actively investigating into. But for choosing our models, this is the sort of process that we've gone through to sort of help select one for that process.
As a follow-on, can you remind me how you decided on the golden answer? Like, is
the
it
golden
just
corpus,
the golden
yeah.
corpus?
I don't know if I can go all the way back, but the golden corpus was just because we had a really good example of the summaries that the first FT were. That's the slide. That the first FT team were writing every day. So it was a nice sort of good summary with a lot of technical parameters to challenge the models and really get that kind of use case to really come alive. And once we'd selected the models, then that allows our testers, which were our editorial testers, our journalists and so on, to choose kind of their use cases and focus on the prompt design and focus on engineering and things like that, rather than focusing on, which model do we use? Because that can really take up quite a lot of time. And so when you have this sort of baseline to help you compare, it's really quite a strong process.
Can I just ask kind of a far-fetched kind of stuff. Would it mean that when you're testing on cosine similarity, that when you're testing using the model, it's actually testing on data that's been trained in the past anyways?
Yes, in some ways. So I think we kind of have this sort of semi-RAG aspect, because what we're doing is we're actually sending the article with the prompt instructions, and we're asking the model to only look at that article. So that's why we get quite high similarity scores, because we want it to only use the vocabulary, the style, the content, and hopefully the facts will come through from using that exact article piece. So I think, you know, it's a tricky place to be, because they do have really broad knowledge bases, but by specializing in the type of input text that you want to support your prompt, whether that's a RAG system or just as we've done, which is just sending the text, you can sort of get a much better output. I hope that helps.
That helps a lot. Yeah.
Thank you so much. I'll let them choose.
Thanks. A really interesting talk, and you made it quite exciting throughout the whole presentation. I came in a little bit late. I hope I didn't miss. Was there a reason for not comparing the models across temperatures 0 and 0.5? Because you would definitely want to see how precise they can be and if they can hold to their precisions, right? Because it's the creative aspect could be quite wide and broad to compare. So was there a rationale, or did you already have like answers where they're all consistently giving out consistent answers between 0 and 0.5? Yeah.
Yeah, no, that's a really great question, a really good point as well, actually. So we had been using 0.7 as our baseline. I think because we're supporting our prompt with the actual article input, there is sort of room for that creativity, and we were sort of looking for that creativity to give a sort of, you know, editorial kind of style to it, but we didn't want it to be too plain as well, because we needed to incite that curiosity gap, which is a very kind of complex aspect. But in terms of the testing, it was just sort of an abstract to see whether sort of going slightly more creative or slightly more restrictive from the baseline we've already been using would make a difference. I mean, in the fact that we chose Claude 3 Haiku, it didn't really seem to make much difference, but in the OpenAI side, temperature is a huge deal. So probably if we were going to opt for that, I would have done further testing to look at the other temperatures. So, and you absolutely can, that you don't have to stick to exactly what I've set up here. You could interchange different temperatures, because I know some people often work at like 0.1, 0.2 and get good results. It depends on how sort of solid you want the outputs in terms of facts, and where we sort of wanted a bit of balance between creativity and that factual standpoint. That's why we opted for those particular temperatures.
And is there any plan to compare these against quantized models or models that run on local machines, like local LLMs? Because the quality will differ quite a bit, but then you can still see how well they perform when they are really shrink down to smaller models.
Yes. So I think for now we're focusing with our connections with OpenAI and Anthropic. I think if we were to kind of lose any of that, then absolutely exploring sort of fine-tuning and sort of hosting internally is something we could look into. But for now, I think we're sticking with sort of the big players that we have access to. We're very lucky in that sense, because they are very strong models. So
thank you.
I hope that helps.
Yeah.
Thank you.
I'm really sorry, but because it's the end of the time, I'll just say a few words and then you can approach the speaker. So thank you all for joining us today at the Data Science Festival. A huge thank you to all our speakers, volunteers, sponsors, and the AV team who made this day happen. Can we please just give them a huge round of applause? And can you please just join us in the control room for our competition winner announcement now, around 5, or at the space bar for networking until 6 p.m. Thank you all again.
Thank you. Thank you.